Good afternoon, lecturers. Welcome to part 2 of our webinar on programming and robotics. You will agree that the presentation of last week was excellent and was in-depth and covered everything that you probably would needed to know to implement this new course in your college. Let's pick up where we left off last week. I'd like to ask Sam to start off with a brief recap so that everyone's in the picture. It's been a week that has passed, so that she bring us up to speed with what she covered in last week's presentation before she can start today's presentation proper. Over to you, Sam, and your fellow presenters. I'm sure you can introduce them as we go ahead.
Yeah, good afternoon again. Good afternoon, colleagues. Yes, so today our focus is going to be on programming and robotics level 3. We also have with us today Mr. Mugotsi. He is going to present for us electronic and digital concepts for robotics, the level 2 and level 3. And the other thing, we have Shailendra Sastry here who's going to assist us by going through the programming level 3 syllabus. What we are also going to do today is to present to you the hints and tips for preparing your students for the level 2 final examinations this year. So like Jan said, I'll give you a very brief overview of what we did last week. So last week we covered the level 2 syllabus. Okay, so we explained the curriculum for level 2, how to teach programming, especially level 2. And today we are here at webinar number 2. So I will come back to this slide. Right. So what we had discussed, we went through all of the chapters in or the modules / topics in level 2. We understood now that the level 2 curriculum consists of students being introduced to computer hardware and software. Problem solving is very big in level 2. Students need to understand how to solve problems. In terms of visual programming, we learned that we use the Scratch programming language and interface, which is very good for starting off programming. And then students are introduced to Python, 2 IDEs. They are introduced to Thonny and they are introduced to PyCharm. So Thonny is a very simple IDE, especially that they use when they're drawing with the turtle. And then when we go on to later sections of Python programming, we use the PyCharm IDE, which offers more functionality than Thonny. So also in terms of Python programming, students need to understand the different data types that we can use when it comes to Python programming, how to get input, how to display output, basic arithmetic operations, and then of course the focus must be on students understanding conditional structures and repetition structures. Part of the syllabus is also covering files, text files. It covers arrays, and then it goes into a little bit more detail on list and list operations as well. So we went through the whole book, and we also will bring it up again as to how our textbook can actually help you when it comes to teaching the subject. So we have a lot of this. Again, is our programming languages that we have in level 2, level 3, and again comes back in level 4 after being introduced to it now. We covered very briefly what the assessments were for NCV. It's the same as it is for all vocational subjects. So that's taken from your ICAS guidelines. The exam breakdown is here, but I'm going to come back to these slides because we will do a presentation on the actual exam for programming as well. Yeah, so again, we discussed what are the benefits of using our textbooks. So in our textbooks, there's a lot of activities. We do what we call try it yourself activities, whereby students can actually follow the textbook step by step and complete an activity and see the output. And then we have what we call test yourself. Now that they know how to do it themselves, then they they test themselves and their knowledge on those particular activities. At the end of each module, we have a summative assessment, and our summative assessment is meant to be similar to what you would expect in a examination, like your trials, like your final exams. So it also covers theory questions, and in the practical sections, we give you the types of questions that could, or an idea as to what kind of questions you could get in the examinations. In our programming questions, we stress on students being able to analyze IPO charts, because that's generally how programming papers go. We analyze IPO charts, and then from there, we develop our software. So we have a lot of activities in our book. We also will have sample exam papers going out with the lecture guides. We have solutions for all activities. We have lesson plans, detailed lesson plans to assist you, and of course, PowerPoint slides for you to use in class. So this was the level 2 syllabus. Those are all of the topics we had covered. So you can see we sent functions and arrays down to the end of the textbook, because that's where our focus will end. But in the middle of the book is all of the important concepts. So Shailendra, I'm not sure if you want to come in now, but that's an overview of what we had done in level 2.
I think maybe just go back to our initial slide. We talk about the webinars, and then just move forward, and we can come back to level 2 again. I think we need to focus on level 3. Yeah.
Am I at the right slide?
Go back to ones on the webinars.
Okay.
Let's introduce them to the talk about the book. Yes. My voice, unfortunately, I'm still suffering with some bronchitis here. The after effects of this. Okay, so just bring it to today's webinar, which like we said, the emphasis here now is going to be on level 3 training, which we couldn't finish on the previous one. And then obviously the big part is going to be training some tips for the examinations for level 2, which is very, very important. Those of you all are looking at starting level 2 this next year. Also, this exam tips will also be helpful to you as well, so you can see what the end goal will be like. And also when you're moving to teaching the course, you have an idea of, how the concept is going to be covered and examined later in the year. So that'll also be good for you as well. Even though you haven't been trained on the content as yet, it'll be helpful to, to have a broad overview of the roadmap, what to expect. So the thing we're going to talk about right now is the lecture training bootcamp. So it was always our intention to have a bootcamp. We were uncertain whether we'll do a physical one or online one. But since our previous meeting webinar last week, we received a lot of positive responses and requests for more details about this. So what we want to request for now is if you guys, those are interested in a bootcamp, a lecture training bootcamp, if you can please Send your interest to the Macmillan email address, gan.krishna@macmillan.education.co.za, and also to textbooks@gmail.com. So what is this bootcamp going to entail? This is going to be a deep dive into the actual curriculum. We'll do a level 2 and a level 3 bootcamp. So we will actually take you into the course content, and we will cover the details of the course. And it's going to be a hands-on workshop, so there'll be a lot of practicals. So it will be lecture content training. Now, this content training is going to boost you and increase your knowledge. You will also attend a workshop from TVET, which is arranged by TVET. But remember, that's on the university level, and they did do trainings last year as well. And a lot of the comments came through were that the university professors gave a high level of training than what you expect at the university. And obviously, we know that at the TVET college, we have a different set of students. So we have a different type of way to present the information. So we want to run our boot camps uh, that's directed towards TVET lectures for TVET students. And like I said, it will be based, because it's going to be based on the actual content itself, you'll be far better empowered. And also, this will now be like a additional training that you could attend and will be very beneficial to you. So we're looking at running physical sessions. So we want to plan that. So we need to know which colleges are interested and where you are. So please indicate in the email which college, how many lectures, and so forth, so we can do the planning, and then we can send out the notices for the applications for the training. So then we can work out the dates and the venues and so forth, and then and the costing that will apply for this. Okay, so that's where I wanted to start off. Sam, you can continue. Maybe we can go on to the level 3 component. Okay, so Samantha did mention the curriculum snapshot, where she spoke about the level 2 concepts that was covered in the level 2 book, and we did mention that some of the programming constructs were covered in level 3, as some of the level 3 constructs was covered in level 2 as well. And we mentioned last week the reasons for that, such as functions, strings, text files, was because you're using the Python language, and also because you needed to use some of those for the robotics practical. Okay, but we did mention that the cognitive skill level for students, these concepts must be mastered at this level. So let's quickly look at that. Reinforcing problem solving and solution development, debugging, input output, reinforcing arithmetic operations, conditional and iteration structures as using loops and if statement, basic validation. This is very important, the validation part, because every programmer needs to be able to write programs that will not just crash. So they need to be able to verify the inputs, functions, strings, data structures. So these are the type of programming constructs that has to be mastered at level 3. There are some level 4 programming constructs as well that's going to be covered in this course, such as introduction to OOP, working with arrays and text files, and source control, and also multi-dimensional. Well, we'll be using single-dimensional arrays in this course, but in level 4, we'll be using multi-dimensional arrays. Okay, and the reason for this level 3 book having constructs that are basically from level 3 and level 4 is because we're using C++ in level 3, and you'll notice it's only being used in level 3. And the reason why we're using C++ is because we're doing robotics programming with Arduino. So Arduino uses C++ as a programming language. In level 2, we use Python, and level 4, you will use Python again because you're using Raspberry Pi, and Raspberry Pi uses Python as the programming language there. Okay, then moving forward into the assessments, and then the breakdown is level 2. Let's go to level 3 breakdown. Okay. Right, so on the level 3 breakdown, as you can see, we have paper 1, paper 2. And this is taken straight from your curriculum document. Okay, so this shows the topics and the ratings. This is also very important, especially when you want to prepare your students. As you can see, the topic 1 on the theory side, topic 1 is based quite heavily on theory, topic 2 as well. But you notice on the practical side, topic 1 doesn't have much practical component in there. That's basically because of the content that's covered. So we're going to go through the actual topics now, and then you can see the reason for this waiting. But please bear in mind this waiting when you're planning out your time. Okay, let's move forward to the next slide. Now move on to let's go to level 3, which is slide 37.
Okay, I'll skip to that now.
So these are covered last week for the level 2. Just move on quickly now to the level 3. Okay, so looking at this, as you can see here now, we have the okay. So we have the level 3 contents. So we have 12 modules in this course. And what you'll notice with our book is that what we tend to do is we use our experience of teaching programming and designing programming books for various levels to work with our actual outcomes and the order in the sense that it makes it easy to teach and easy for the learner to grasp. It's important to know that there are building blocks, and we follow the sequence according to how the building blocks needs to be applied. So cognitively, you'll find that the student will be best uh, prepared following this type of sequence. Remember, the curriculum document you have is just outcomes, right? And outcomes are designed very differently, and they're not always designed to be taught in that order. So it's important to bear that in mind. Okay, so let's have a look at, so we've got module 1, computer hardware and software. Module 2 is problem solving. Again, these concepts are recap on level 2, but now we go into greater detail. Okay, so now we go into greater depth. I'll unpack this depth just now. Module 3 is dealing with concept of single board microprocessor and microcontroller. Module 4 is programming tools, utilities. Module 5 is instruction to high-level programming language. And then we're going to be making use of the visual programming language there. Module 6, we'll be using data variables and outputs. We're making use of data types as well. Module 7 is making use of math functions, inputs, constants. Module 8 is selection. Module 9 is repetition. Module 10 is using functions and modularization. And module 11 is arrays. So remember, we do not go into multi-dimensional arrays in level 3. We only stick with single-dimensional 1D arrays. And then module 12 is the instruction to do. So remember, we did explain the cognitive levels of development for a level 3 student. What a level 3 student needs to master? They need to master up to this point here on functions and arrays. So the issue on OOP is more level 4, even arrays as well. Models, especially moving to multi-dimensional, is more. So arrays is like level 3, level 4, and OOP is more something that's really going to be mastered level 4. So this is an introductory module. So this concept is going to be introduced to them in a very basic, simple way, just to get them started into OOP. We're not going OOP proper. OOP proper will be covered in level 4. Okay, let's move into the next slide. Right, so we're going to talk about the IPO cycle. This is very important now for the students because they are doing physical computing, right? All those lectures during level 3 all know what I mean by physical computing. So obviously this is something that's going to be unpacked now to the students in greater detail, exactly the different components of the computer and how they are used for the programming process, for the inputs, outputs, and processing. So we're going to go into great detail about the CPU, the RAM, and so forth. So if you look at now into the next slide, we're now talking about memory. So we're going to great detail. What is the different types of memory? How do they all work? What is the functions? The examples. This is very important because when you look at the students are making use of the mobile device, which is their own form of the computer. We have a desktop device. We have the Raspberry Pi, right? And each of those devices make use of memory, and there are different types of memory found in each. Even students walk around with a storage device called USB, whatever memory is being used there. So this will be unpacked in those examples, so the students will be able to understand how those memory devices work, what are the advantages, disadvantages, and more importantly, the main function of it. Moving to the next slide. Okay, so now get into the practical part here in level 3. So in level 2, we made use of DOS commands. In level 3, you can see here now we're going to be again working with command prompt, but in this time around we're working with Linux. Moving forward to the next slide. Okay, so what to bring to your attention is that when we cover in the books, you notice that we do the explanation of the concept and we take you through step by step with explanations how to the student to do the perform the task step by step with screenshots. So this is gonna help the students to remember and also to apply the work, especially when you do it on your own. All right, move forward to the next slide. Okay, so module 2, dealing with problem solving and the concepts and solution. Now, I've been lecturing since 2000, so it's been a long time in the field, and I've lectured to diploma students, degree students, uh, high skill, high performance students in world skills, and I can't emphasize. I've also been involved in industry as well. I can't emphasize the importance of being able to teach the student how to understand algorithms and how to understand how to problem solve. So problem solving in algorithm is essential to any developer at whatever level you're going into. So these students now need to grasp this. And also, those of you in level 2, you already know this, you've already been experienced this, that students struggle with these things, right? They don't like things like IPOs, they don't like things like flowcharts, pseudocode. It seems very routine for them, and it's also something that they find very boring. But please emphasize this in level 3. So we do recap on these concepts was covered in level 2. And if you look at the book, what we do, we keep our style very consistent. So what we have here now, you have the syntax that's going to be explained in the syntax box. That is how to use if then else statement, for example. And then we break it down in the let's break it down box, explaining each thing. So in level 2, when you do this with the students, it was pretty high level. It probably went past most of them. In level 3, you'll find that they're more going to be more receptive to this. So if you go back and you're gonna emphasize the detail on this, and maybe run some quizzes with them in class and get them make an interactive session, you'll find that they are going to engage in the content because that's what you want them to do. You want them to really engage with this so they be able to start to like the algorithms of how the design process works. So what we've also done in the book to assist you is that throughout the book, when you get, especially when you get to the practical part, right, you'll notice that in this module here, we're going to cover how how to work with algorithms, so how to take a problem, how to break it down, problem solve it into the IPO chart, its inputs, process, outputs, and then how to design it using the pseudocode and the flowchart. And what we've done is we'll take the same problems. So in this module, you're going to be designing them, right? So explain to the students how to understand the problem, how to break it down, and how to come up with your designs. So what we've done in the book is that we've used the exact same problems now later on in the practical components. So you'll find that when you get to the practical section, you'll find that the students will have problems that they've already designed previously in this module. So this is done very deliberately. So what's going to happen now, we're going to emphasize the problem solving process with the students. And when we get to the practical components, you'll see we even have the IPO and the, the algorithm, the flow chart in the actual design before they get to the actual code. So the students see their growth from moving from problem solving to design to implementation. So remember, we teach the scenario based on the problem solve it into your analysis, into your IPO chart, then design from your IPO chart, which is your analysis, design it into your algorithm, either pseudocode or flowchart or both, and then eventually go into programming and go into testing. So testing is very important aspect, and I'll unpack that at a later stage. Okay, moving to the next slide. Okay, so module 3, we're going to have, so remember when the curriculum designer designed the book to interact between different subjects, right? So programming is linked to robotics, it's also linked to electronics. So in this module here, we're now linking to robotics. And remember, these concepts were covered previously in level 2, in the robotics subject, where we learned about how the different components work. But now we're going to be dealing with Arduino board. So there is this the linking between the two. So there is a bit of robotics programming in here. Now, when we cover this in the book, what we have done is that we go into the theory of the Arduino board, the components, how it all works, and then explain this to the students. And then what we've done is that we've moved towards the programming part. But in the programming part, what we've done is that we've tried to put it later on in the book. So what you're going to find is that we've actually made use of simulators to show the students how to do robotics programming. Now, this is directly linked to the robotics subject, right? So we've chosen some examples that are not going to be covered in the robotics subject itself, but they're going to find very, very exciting and very practical. And we use a simulator for that. So even as a programming lecturer, we can still show them how to be able to do the entire simulation and do the robotics programming, right? Those of you who are taught level 2, we understand the challenges faced with getting equipment on time. So the use of simulators is very important. So this is what we've done. And you won't find those the simulated examples in the promo copy. Those will be in the final copy. And what we've done, we've moved them at the end of the book. And why it's done at the end of the book is because the coding in there is basically C++. So it makes no sense to bring in the coding in now in this module because the students haven't done C++ yet. So we brought it at the end of the book after the students have covered C++. So when you can attempt those examples, they already understand the code and they'll be able to work from there. So in level 3, we also make use of visual programming. In this case, we make use of MBlock. So MBlock allows you to work with Arduino. It's also very, it's quite a powerful package, even though it is block-based. So it's very similar to Scratch. But there's a lot of features in there that are very similar to some of the industry type packages. So you find Scratch is not really used in industry. It's just meant for schools, for educational point of view. MIT designed it purely for educational purposes. MBlock, on the other hand, was meant as the intermediate block-based language going to industry. So those of you that are involved in a world case competition for robotics or got your students registered this year, maybe some of you want to join next year, you find that the version of MBlock can be used there. Those of you working with Festo as a company, a robotics company, you'll find that they also use a version of block-based programming, which is again identical to MBlock. So MBlock is an intermediate one. It's actually going to help the students to go into the industry type of usage. And the good thing about MBlock, it also takes the block-based code and converts it to actual C++ code. So the students can see what C++ code will look like on the block-based programming. So that is quite nice. So what we've done here now in this section, so we try to keep the robotics programming out of it until the latter part when they're more comfortable. So we choose examples in MBlock that's going to more stimulate them. So we made use of things like games and stuff like that. Because students need to make this exciting. They need to be stimulated so they can get excited to the more harder coding, right? So block-based programming is easy. So that's the reason why we've done that. Then moving into module 4, we now go into C++. And as you can see, we will show you how to build the app, run the application, work on the desktop, and the Pi. Okay, so in this diagram here, so in this module, you can see what's going to happen is that students need to understand now how the actual programming process works. So they wrote the program, how the program works. In level 2, we didn't go into detail. In level 3, we now unpack the detail. How does it actually work? So in C++, we make use of a compiler, right? And which is different from Python. Python doesn't use compiler, so we explain to students how the compiler works, which is C++. What happens to your source code, right? And we explain the process. But very important, what we've done here is we make use of graphics. So we see we've got a visual diagram in here, and we make use of color blocking in the textbook. So we find the use of color blocking very strong in our books because now when the same concept is covered later as examples, the students see the same colors and it starts to link with the diagrams to become a visual process. Okay, moving forward to the next slide. Next slide. Okay, so we make use of visual programming tools. So for C++, we recommend make use of VS Code. So we did a lot of research in here as to what is the best IDE to be using. Remember, IDE is going to be the tool that you're going to be using to create the program, all right? And more importantly, what I've noticed is that when you move students from one IDE to another, it's very important to understand that is a learning curve, right? And that can also be a hindrance as well. And when the students they get empowered on a particular IDE and they want to apply themselves, like say, for example, out of college now, they apply for jobs or they get involved in other projects, right? The IDE that they learned in college within their course, if it's also an IDE, there's a popular IDE out in industry. That's an IDE that's also popular if they want to expand the activities into other type of projects and competitions and so forth, like the world skills, then it's best to use an IDE that's really going to assist them. So we did a lot of research and we found that VS Code is the best IDE to use for C++ because one, it is the most highly adopted IDE in industry. So when these students will go to industry and because they're comfortable with VS Code now, you find they can easily now go and work in that environment, right? Remember, even in the interview stage, I ask you what language you use, what IDE they're comfortable with. And if students say, well, we're comfortable with VS Code, they're already going to be at an advantage going there. Also, we also know the Microsoft packages are tailor-made for student learning. There's so much of built-in tools in there that makes life so much easier for you. As you want to expand and then you go into more deeper code, you find the tools are already in there and they're more simple. So things like code correction and auto completion. So as students are typing, the the code starts to complete itself. The tips come up. It makes it so much easier for the students to prevent making simple mistakes. It helps them in the development, makes the development faster, especially if there's coding errors. When I teach my students, even especially at world skills, I encourage them to make use of intelligence. So it actually limits your coding time, it limits your mistake. Okay, so there's a lot of features. Also, a big part of VS Code and why we went with it is because of its automatic integration into Git. So remember, Git is going to be big. We're going to Git this year, but it's going to be a huge part again in level 4. And Git is now a massive part of programming. So VS Code is automatic integration. There's nothing you really need to do. So it makes it so much more easier for the students to work with it. That's why we went with VS Code as IDE. Okay, so we're going to cover simple programming now in Module 5, the Hello World program, and the C++ application structure. Move into the next slide. Okay, so what we've done is that we've annotated the GUI, so it's very easy. So when you explain the GUI to the students, the different components of the GUI, what they all mean, where's the file menu, where's the code menu, the error list, so they can see everything, how to run the program, the run button, and so forth, how to do the management tools, where to go there. So by annotating the screenshot, it's very easy for you to now get them started. And even if they get into the program and then they forget now, they can easily go back and turn back to the page and still see the diagram, right? But if you just demonstrate once and they've got nothing to visualize from, if at the later stage you need the same assistance, it doesn't really help them. So that's why we made use of annotations. Okay, so we've also used, again, our style is when we demonstrate something, we like to use what we call a try to solve activity. Again, this is we do things right from the outset, right from the beginning, step by step, covering every single step, show them how to open an application, what do you do, what is the next step, the third step, the fourth step, the fifth step, and then you have the screenshots that will appear on the right hand side for the various steps as the students go through the various steps. This now technique now shows the students how to do it step by step. When you use demonstrating in class, it makes life so much easier, especially because we have the PowerPoint. You can present the PowerPoint on your projector, and the student can follow from the textbook, and they can do the activities. And then at home, when they go back again, they're trying it, and they use the book again, and they now follow from the book step by step. So they now reinforcing the knowledge on how to do the work. Okay, so we go to quite detailed step by step. Module 6. So in Module 6, we're going to go into the data types and variables. So we've taken screenshots of different parts of the book for the different modules. Obviously, we can't do the entire module. You have the promo copy for that. So I'm just going to unpack some of the key features. So looking at data types, again, data types is different now from what you find in Python, right? So C++ is your more conventional programming language. Remember, C++ comes from C, right? Which was one of the main high-level languages that came through, and that was the real sort of start of high-level languages. And C is still used even up to now, even though it's so old. So it's basically what the grandfather of programming languages. Um, I learned C++ when I was in university. That shows my age. That is really, really at the outset, and how nice it is that we're now coming back to C++. Um, it's a very, very powerful language, but at the same time, it's a little bit of a technical language. So there are aspects about the language that the students need to understand. Python is more user-friendly. So what we've done here, when we get into this module, you see that we try to unpack the differences. We try to unpack the details of how C++ is used, the different components, the data types, how the data types work, integers, floating point, what they all mean, uh, comparing integer and floats, how are they different? These are concepts the students are not really going to be 100% trained on from level 2 because the way Python works. Okay, so you all understand that point. So we're going to C++, they need to understand that difference. Okay, so again, we go into working with variables. We unpack you we start off with unpacking what a variable is, then we go into the syntax of a variable, and then we go into the explaining what the syntax is, go into the example as it's color coded, annotated as well, and then the explanations on the left hand side here to explain the different parts of it. and then we go into more explanations, and then we go into examples. So let's move on to the next slide. Okay, so before we go into examples, we cover operations. As you can see, again, everything is annotated to help you to unpack to the student how the operations work, the order of precedence as well, how is it going to work in C++. Okay, and in module 7, then we're dealing with keyboard inputs. We'll also be dealing with constants, dealing with math functions, and also dealing with errors. Okay, move forward to the next slide. Right, so dealing with input and output. So in C++, we're going to be making use of C, so scanf and printf. So scanf is going to be for inputs, printf is going to be for output. And then we also can make use of C in and C out. So there is a bit of a difference between the two. C in, C out. Let's go back to the previous slide, Sam. So C in and C out, it's going to be unpacked in greater detail much later in the book. Okay, but we do use it earlier, even though it's explained greater. The reason being is that C in, C out makes use of what's called streams, right? Now, if you're going to explain the concept of streams to students at this early stage in your course, you are really going to confuse them. So what we've done is that we show you how to use printf and scanf, and then later on we show them how to use C and C out, and then at the end of the book, when we get into concepts of OOP, then we explain to them how streams work, because then they'll be able to understand what is actually streams. Then they'll really be able to tell the difference between C in and scanf. What is the difference between printf and C out? At this stage, if you want to unpack that detail, you're going to lose the students. Okay, so like I said, we have the examples step by step. Moving to the next slide. Okay, and then we have our activities. You find our activities are very, very varied. So we have your test yourself activities, and when we're having these activities, we think about the lecturer. Okay, so after you do a particular type of example, right? What is the type of activity that you really want to have next? So, like, what knowledge do you really want to test? So, at this stage, what we realize is that you want to test to see if they learned what is a character literal, what is a string literal, right? If you give a simple code, right? Refer to C++ code, and what would the output be? So see if they can be able to understand their code. After they've done the various examples, so a whole lot of examples that were done. Now you're testing to see whatever information. You don't go to detailed, heavy-duty programs at this stage, because right now you're introducing them to the concept. So the type of activities that we have that you see in the book, and they deliberately placed in different positions in the actual module. So at this stage, at the early outset stage, the activities are based on testing to see if you understand the basic stuff. And as you go more on into the module, then you get the bigger, more intense activities that now allows you to do more comprehensive programs. So let's move on to the next slide. So obviously we could not showcase all the slides, all activities from one module, but you see when you go across other modules, I'll show you the different types of activities that we have. Okay, so now looking at module 7, now we're dealing with math functions, interactive input, constants, errors. Again, we'll make use of, we'll define the concept, explain the concept, and then after go into examples, right? So you see, looking at errors, error tracking is so important for every developer. It's important that we get them a little bit at the earlier stage. So because as they start coding and they encounter errors, they need to know what is the error and how to fix the error. So what we've done in the book is that we put in errors in there and we showed what the error window would look like. And then we explain what were the different errors in there. So they will help you now. So we try to cover the main errors that you're going to cover, that the students are going to encounter in this course, and explain to them what the error is and how to fix the error. So this is quite important, and we try to do it as user-friendly as possible to help you as the lecturer. Move forward. In Module 8, we're moving to your selection control structures. So obviously, we do relational operators, which is a recap from level 2, and then selection statements and validation. So validation is something that's going to be quite important for the level 3 point. And then dealing with nested loops. So even though some of these concepts are covered in level 2, in level 3, we now go into greater detail, and more importantly, with C++. Okay, so selection control structures, how is it covered in C++? So what we've done, look in the if statement. Again, we'll always start out with the syntax. So what are the rules for following the language? Remember, C++, the rules are very different. C++, we have curly braces to show your blocks, right? So open curly brackets, close curly brackets to show your blocks in your code, whereas in Python, you use indentation, okay? So this is unpacked in the syntax. And then we have the explanation of the syntax, how it all works. So you can run that through with students, and also the students on their own can also recap and look at it to digest it. Then we have examples, and like we try to make the examples as interactive as possible. So we have annotations, and then we also have explanations on the let's break it down. And then in the example, we also have the sample output. So to just look at this, you can see when we run this code, this is what the output is going to be like. It helps you with explaining as well. So they don't even have to run that code. If they do run it, they'll see what the output is. Okay, and then we go into an activity. So remember the try to self activity, what we're saying is once you explain the concept, you cover the example, the try to self activity is now where the students are now going to try it on their own, and we try to break it down. But in this type of problem here, where you can see a little bit more complex problem, you can run it through with them first, and then they can try it. Okay, so as you can see, we have uh, how do you apply this to problem solving? So we have a problem in there. The problem statement is provided in the scenario. We have it broken down into the various steps. So remember, we explained the problem solving process in the earliest module, all right? And then we're now using the exact same steps again, so they can see problem is analyzed, broken down into the IPO. From the IPO, after you analyze the problem, how do you design the problem? Here we make use of sample flow chart for designing the problem. After you design the problem, how do you go to code? This is very, very important to teach in this way. Because remember, guys, in the final exam, the students are going to be given a problem, and it's going to be a big problem, right? So you have a big problem, but in the problem, there'll be hints in there that's going to help the students to problem solve. So normally what happens, you give a big problem, big scenario, and then you'll get an IPO. So the analysis is sort of done. So the students are trained from the outset, from the scenario, you go to IPO. From IPO, how do you come up with your flowchart? And from your flowchart, how do you go into code, right? And when the students go into the exam environment, they are now trained in the same way. So when they see the problem statement, then they see the IPO, they say, there we go. These are the inputs for this problem. These are the outputs for this problem. Okay, these are the processes, these are the functions, those are the actual formulas that we need to be using. So they need to understand that's the formula I need to use instead of guessing what the formula is. Okay, so from here, how do you go to the code? So we explain that and then we unpack that again in greater detail, explaining it to the students. And then step 4 is testing. Remember, testing is a very important part. So we cover unit testing in all our activities. So we shouldn't be testing and then what the output is going to be. So it's going to help you as well with your pens. So students know when they come to do your pens, they're going to do the design, the analysis first, then do the design, the flowcharts to the code, they're going to do the code, uh, and then they're going to do the testing, and then they're going to show you your outputs. So this will train them on how to be able to work in that environment. Okay, continue. All right, module 9. Module 9 makes use of loops. Now, this is very important for robotics. All of you are in level 2, you've all been exposed to this. You know how important to use the loops, especially in robotics programming. But now, the different types of loops, It's always going to be an issue, but now we're dealing with C++. How loops are used in C++ is different from Python. So we are now going to unpack those in this module. Okay, so how do we unpack it? So we unpack it by showing them the syntax again. So these are the rules. If you're using the while loop, that's the rules you need to follow for C++. While you have your open brackets, your condition, your curly brackets start the block, and close the brackets to end the block, and what code is going to be, your code is going to be, and that's the code that's going to be repeated. And then again, that's going to be explained in your break it out section down the bottom. And then we move on to the example, and as you can see, there's now a simple example which is annotated, explaining everything, and then you got a sample output in there, and then lines, very important. You can see the line numbers are explained, what is happening in each line, to explain to the student now, so they can match syntax to the actual example of how it actually works. They can type this out, and they should get the same output as well. And then from there, they can move on to the try to solve activity. Move forward to the next line. Okay, so then they can move to try to solve activity. And as you can see, all try to solve activities follow the same system. You have the scenario, you have your breakdown, your analysis into IPO, you have your flowchart, which is design, you have your code, explanation, and then you have your testing, which are output. Okay, so again, what we said as well, we tried as much as possible in your try to solve activities. Now in these practical modules, we try to use the same questions we gave them in the design module, right? So now they can see the same design, and even the questions we give them as activities, tests of activities with students to work on their own. You'll find that we use some of them here as well in the programming module, so they can see now these are the solutions and how do you go from design to code. Okay, this part here, your test yourself activity. This is again we did mention there are different types of test yourself activities. Again, testing different things. So you can see now after doing the simple program and you got your output now, okay, then what do you want to do? Well, what do you really want to test? In the classroom, you're not going to ask the student to do a 30-minute activity. You want to do a short activity just to quickly see if they have learned what you just demonstrated now. So a short problem, right? Based on your example, it's very important. Based on the example, right? That's just explain now the tier one activity, and then now you want to ask the student now do this on your own. So, and it's a short, so you're not for them to be able to manage it. And then from there, then we now migrate into later on in the module into more challenging activities. As you can see, activity 19.18, we now become more, the activities become more challenging and more in line to what they can expect in the test and an exam as well. Okay, also very important that look at activity 9.19, the type questions we have here now. Testing different type of skills, right? Not always writing the code. Okay, we also wanted to analyze the code. Okay, so look, if you look at this one here, it says now select the most appropriate answers from the options given. So they want to know how many times will this instruction in the loop in the body the following code be processed. So you wanted to see, do they understand how this loop works? How many times the loop is going to run? And then we give them the options now, and then now they're going to pick and choose as an MCQ. And there are more activities like this. So we have different types of activities to test the students in different ways, analyzing the filling missing code, analyzing code, producing sample outputs, you know, analyzing code and choosing from a group of options from MCQs. Because when you see group of options, it's like more familiar to them. Right, then module 10, then we have variable scope. We're also going to have functions, modularization, and a big part here, random numbers. Again, when you're working with robotics programming number 3, you're going to make use of random number functions quite a lot. Okay. So modularization and functions. Okay, so we're looking at here again to start off with the syntax. What are the rules for using functions in C++? We've done it before in Python. Now in C++, how to do it. Remember, now in level 3, they need to master functions, and functions done in different ways. So we have void functions, we have functions that return values, functions that don't return values. So we call them functions that don't return values. We call them void functions. Okay. We have the function prototype, which is like your header, and then we have the body of the function, which we call the definition. So all of this is explained in the book in great detail. So we have the syntax, we have the explanations, we have the syntax, we have the explanations. Okay. So these are just snapshots of the different types of functions that can be used, parameter functions, non-parameter functions, how do they all work? Move forward to the next slide. Okay, and then more importantly, then we go into the application of it, right? So we're going to try this out. Now you see, this try this out is kept a bit more simpler. It's not the more intense one that does have various steps. Because why? This is more like an example. Okay, so but it's kept short and simple for you for the students to really grasp the concept now. So they explain now what is the function prototypes, where are they, where the actual function is defined, right? The function call. So those are the things now that's going to be explained in this example. Again, we have scenario, well, what this example is going to do, code itself, and then the steps on how to run this program, and then what the sample output is going to be. Then after that, then we have a test of activity. And as you can see here now, if you look at this activity, uh, it's not so intense. It's asking to create a full program, but doing it in stages, right? This is write a function prototype, a function called find max. Invoke the function find max inside the main. So it is like we're asking them to do the different parts of the program now. The function prototype, calling the function, which is another word for invoking the function, create a function, definition, and so you're asking them to create the different parts of the function in one activity, right? So different parts of the program in one activity as sub questions. Also, it's also going to train them for the exams. In the exams, they will be asked, especially in the theory question paper, they will be asked in this way. They have the right code, step by step to do specific things. Okay, so that's what this test yourself type of test was used. Move forward. Okay, module 10. Again, like I said, we make use of math functions. So we've got some here like the round, the SRAM, the random functions. Okay, generating random numbers. How it can be used in C++. Again, we show you, we explain the functions, how they work. We explain the syntax, what are the rules for using them, the different functions, and then we do the example here. Try this have activity, right? With the students nice and short, so they can see it working quite quickly, and what the sample output is going to be, and then from there they can go to more intense problems. Okay, move forward to the next slide. Okay, so module 11. So remember, we can't unpack all parts of the module, right? It's just not enough time in the presentation to do that. If you guys book the training session, then we'll do hands-on training, practical, like you are sitting in a classroom. So we can, once you go through that level of training, we're really, really comfortable to deliver the lecture because you've attended an actual class yourself. Okay, module 11, we are unpacking arrays. But remember, module 11 in level 3 is we're focusing on 1D arrays, right? 4 is where we cover multi-dimensional arrays. Okay, move forward. So in Python, you have to do arrays and this, right? So in C++, we explain how arrays are used in C++, the concept of arrays, and we explain 1D array, 2D array, a multi-dimensional array to understand the concept itself, the definition is there, and then we unpack the components. What are the different parts of an array? And we got so here we use an example of the data. If the data was stored in memory, if you use an array, right, how does data get stored in memory, and the components of the array, such as array elements, the index numbers, what they all mean, right, the actual data itself, how index numbers are from 0 and so forth, and values that are actually going to be stored in memory. And then let's explain and let's break it down section. Okay, and then we also really important because it's different now from Python. So we unpack a bit more information about arrays. How do arrays work? Well, what is the concept of arrays? Arrays is also a very challenging topic. Even my level 4 students are also struggling with arrays. They don't normally get them very easily. So as much information you can explain to them and go through them, it's going to help them. So what we've done here, because it's such a challenging topic, just go back to previous slide, Sam. Because it's such a challenging topic, we showed you step by step. Let's go back to the previous slide. Sam? Okay, so unfortunately, Sam skipped that part. Um, Yes, so what we've done, we broke it down into the various steps. What are the various steps of using an array? So there are 4 steps to declare the array. Step 2, you store data in the array. Step 3, you perform calculations. And then step 4, you want to be able to display the value stored in the data, right? So we explain to them how to do it step by step. And then when we covering now how to use the array, we explain what the steps. So say now, this is step 2, storing data in the array. Store data in the array, syntax. What are the rules in C++? How do you store data in the array? Okay, and then we show them an example as well. And then we have a test yourself activity. Uh, that's gonna simple one that will cover quite quickly in class. So this is now, because remember, you don't want to take too long between step 1 and step 4. So you're gonna move through that. So those activities now are designed more like class activities. Very quickly, you can continue in the same lesson, right? And then we go to initializing an array. What's the difference between declaring and storing and initializing? That's covered there. Okay, so yes, this is what I was talking about here. Looking with arrays in C++, the 4 steps. What are the 4 steps? Step 1, declare the array. Step 2, you store the array. Step 3, perform calculations. And step 4, you display the data. Step 1 is declare the array, the syntax, the rules, explain, and then we'll do an example. Okay, so you can see we've done it like that. Move forward to the next slide. Next slide, sir. Sam, you can go to the next slide. Okay, Sam was having connectivity issues. Sorry about that, guys. Okay, so once we cover the various steps, right? How to do step 1, declaring the array. Step 2, storing data. Step 3, calculation. Step 4, display the values. Then we do an example, right? And then I can see try yourself activity. We have a scenario. Again, we have the IPO broken down, and then we go into the code, showing we now applying the various steps now of working with the array, declaring an array, storing data in the array using a loop, and then you performing calculations, and then displaying the data. As you can see here, we're also calculating average as well. So we're performing sum and average, and then what's going to be your output, right? After testing the program, that's the output the students will see. Once you've done that, then the students can now get to your test system activity. Now you can see these are a lot more intensive now, right? As you can see, the mark allocation, time allocation is 45 minutes. These are meant more for them to do at home now. Remember, when you're doing it at home, because the book is done this way, scenario, IPO, written code, you can now ask them at home now. You go now, this is a scenario, break it down into your IPO. From your airport, break it down into your flowchart or pseudocode, and then write out the code in C++, as you see in the example. Okay, so you're now getting them to work it out, even though they don't have the computer. Very importantly, when they come to class now, they can try it out in class. They've already thought about it at home. They already come to the college with the page, and you can, if you're going to check the code quickly with them first, or maybe just look at their code and then give them input, and maybe you put your sample code out there, and then they try it in class, and then they see a working program. Because we know we have limited time in this course. So it's very important to make use of the self-study time. Very, very important. Self-study in class with simple try yourself activities. Self-study at home with your test yourself activities, where you now attempt the problem solving at home, come to class, just type it out and test the solution. But more importantly, give them feedback before they test it. Don't let them try out a program that's heavily completely wrong, right? They're just going to waste time in class. Move forward to the next step. Okay, so we mentioned the different type of activities. At the end of every single module, we have our summative activities. These are very intense activities, but the question styles are designed to help prepare the students for tests, trial exams, and final exams. Okay, so if you look at these type of activities here, you'll have different type of questions, MCQs, try to test just definitions, what you call this, matching. So we covered a wide range of questions, problem solving. What is the code? Fill in the blanks. And then also we have the full complete uh, problem solving where they have to write the entire code. So this type of question now will be required for them to do it in the if they were in the practical exam, right? Or even in the assignments. So we use a wide range of activities to help you with it. Module 12 is OOP. I'm going to go through this quite quickly. Fundamentals of OOP and string class. Let's move to the next slide, sir. Okay, OOP is a very, very complex topic. I can't explain to you how complex this is, and students really struggle with it. So, in instruction of OOP, we'll try to make it as simple as possible to explain to them what is an object, what is a class, right? So your class is more like your design, like your blueprint. If you know, if a company wants to go build cars, they'll come out a blueprint of the car. That is your class, and from that class, they can create many objects, which means they can build many cars. The actual car, the work that comes out of the production line is an actual object, right? So once we understand that concept of a class and an object, how it works, and then we can go into the applications of it. Like I said, in this example, in this module, we'll cover string classes as well. And we'll also explain to them about C in, C out, what is streams, how streams work. Uh, there's a bit of a complex explanation, but simplified in a way that the students can understand. Remember, they only do C++ in level 3. They don't do it in level 4. So we don't go overboard, yeah, and kill them on the high level stuff. They just need to know how to apply C in, C out, and what is streams and how it works. Okay, so again, we talked about the different type of activities that we have to reinforce learning and to prepare you for the exam. We've got try yourself activities, test yourself activities, summative activities, examples. We've got case studies in there designed for the test that will be provided to you in the lecture guides. Okay, and also what we've done is that we're now making videos for all the try yourself activities. For the moment, we said we want the students to be able to do it on their own, so we're making videos for you that will be provided for you. With the, so the students can be able to watch those. Okay, so what we're going to do now, we're going to move into the level 3, so the level 2 exam tips training. So Sam will take over on that part.
Thank you, Shailendra. So what I'm going to do is just get back to my slide on examinations. Okay, so for our level 2 examinations, so we've already covered our level 2 syllabus last week. We did a quick recap today, and then we also covered the level 3 syllabus. So right now, the colleges that are currently offering this course, you are busy doing revision, trying to get your students ready for exams. And we did get sample exam papers from the curriculum designers. But what I wanted to stress is that these curriculum designers are from the universities of technology, and they may not necessarily be the examiners for these particular papers. So when it comes to preparing your students for final examinations, I'm quite sure that examiners will follow the structures that we had for previous programming subjects. So in terms of your programming paper 1, so some exam tips here for starters. We know the duration of the paper is 2 hours. It is 100 marks.
Yeah,
A lot like
if I can just come in here quite quickly, sorry about
yes.
that. Yeah,
Sorry?
just to emphasize this part again, guys. So this is now your first year we are running this course, right? So you're going through the trials of the ICAST, and we made them internal, where we all work together, as lecturers, and also the practicals, and then we had for the sorry about my voice, and then we had for the ISATs was done externally. Now in your exam, you'll find that it's going to be an external examiner that set this paper. I was going to give you guys some idea from our experiences with other subjects. Like with computer practice, we had something quite similar. Completely new design for the program, very similar to how robotics came along, right? And just like how Cisco was identified to help with IT and computer science, also identified to help with the robotics and the computer practice as well. I was very heavily involved in there. And what I noticed as well, we had sample papers that came from the professors from the universities, and unfortunately, it did not link very well to the actual exams just set by the examiners. But the examiners that we use are mostly from the TVET sector, so they understand the sector quite well. They understand the outcomes of the course quite well. So you'll find when you are preparing your students, you got a sample exam is a sample exam template. This is something to practice with, right? So bear in mind that is not necessarily going to be that way. Now, why I'm mentioning this is that there are some specific things that they've done in that sample paper that won't necessarily be used in our TVET exam. So when we start going through these tips with you now, please listen to these tips quite carefully. That's going to help you to prepare your students for a TVET exam. Continue, Sam.
Thank you for that. Yes. So in terms of our theory paper, we generally break it down into 2 sections. That's what it looks like. So section A is usually your short answer questions, which could be approximately 30, 35 marks. We are approximating here. So again, the kinds of questions that we get asked in section A would be multiple choice, true or false, matching columns, choosing words from options given in brackets. They may give you pictures of components, hardware, especially to test the hardware section. So they may have pictures, and then students will have to like name components. So those are the kinds of short answer questions that might be in the theory exam paper. When it comes to section B, this is your medium to long answers that are required, so approximately 60 to 70 marks. So first off, we'll have general theory questions like definitions, explain this, list terms, list items. So those kinds of questions focus mainly on the theory sections from the syllabus. So you have to ensure that your students understand the theory sections very well.
Okay, it looks like Samantha is having some technical challenges here with connectivity. I'll just continue quickly. So to prepare you for these type of questions, you'll find in our textbook our summative section at the back of every module where there are questions designed just for that module itself. So they are in line with these type of questions that you would see here. Okay, so you also need questions such as number conversions, code snippet analysis, where you get a piece of code, analyze the code, what is the output, or there's something wrong with the code, correct the code, what is the line of code, or explain what is wrong with the code. So code analysis, remember it's a theory paper, but it's still going to test some level of practical, right? And how they test it is by asking code snippets because there isn't time to do a detailed big program, right? Problem solving is also a big part of this course. Problem solving will be covered, and like we mentioned, uh, I'm just quickly replying to Sam. Okay, so problem solving will be covered where they're given a scenario, and from the scenario, they must create IPO or flowchart. And you notice that it's covered in one of the modules in the level 2 book. You also seen it in the level 3 book now as well, right? Unpack that here. So you can see how important problem solving will be. So it's guaranteed you will see that in the paper. Those of you all who teach in IT and computer science, the level 2, you know yourself. You've seen every year, you will get IPOs, flowcharts in theory paper for problem solving. Even level 3 lectures will also see it as well. So that part is guaranteed. In the practical, I see Sam is back. I'm gonna go and
Yes,
take
sorry
over.
about that. Okay, you can continue.
Okay, so in the practical, it's a 3.5 hour paper, 100 marks. This is a big problem. I don't know how you try the exams went, right? But from our experience with NCV, I think computer science, students always struggle with time to complete the papers. So you're gonna have to give them some tips how to manage their time. And from the question paper, I did mention to you when you get a question paper, you will always have a scenario and you always have the IPO. So for the problem solving part, the student needs to know how to interpret IPO. The formula is already there and how to do the basic thing. You just declare the variables, just use the inputs, use the same functions again. Use a loop, how to use a learn how to use a loop and put the loop structure in there. Uh, if you're using arrays, how to make use of arrays. If you're using constant, how to declare the constant, the calculation part, and also to display. So if they can master those concepts, right, and you use generic questions to help them with that, they don't have to make the program run 100% and and it will be fully functional to be able to pass. That's something they need to understand because we are also going to be marking code as well as output. If the program runs 100% excellent, if it doesn't run, they don't get output, they will still get part marks, and there's a lot of marks to be achieved, especially for the challenging questions. So you'll find in this paper, you'll find that generally looking at our topics, right? So in the programming part, we've only got three type of programming that's covered in this course. We got Scratch, we got Turtle, and we have Python programming. So when you are preparing the students, prepare them for the Scratch. There's a whole lot of Scratch programs that are done in the textbook that they can use to prepare them for the Scratch part. We're estimating what the layout will be, sort of breakdowns that could guide them for where marks are concerned. And then we've got Turtle. Turtle activities again are also covered in the book. So remember when we also explained at earlier workshops on how to prepare exam papers. Every exam paper must have a structure to it, right? So you need to have your level 1, level 2 type of questions. So your entry level, where the students can score their marks, and then but intermediate and more higher level questions. So your Scratch and your Python will make up your more or less your entry level type of questions, right? With this questions are quite simple. But there will be some components in there that will be sort of higher level questions, right? So if a Scratch question 30 marks, all 30 marks of it will not be allocated to all what we can call easy level questions, right? Low level questions. Some of it will be, could they maybe ask them to do some activities that will be a little bit more higher level. So there will be a mixture. But what is guaranteed, you'll find in the practical paper that there will be a balance. You will get 100 marks, the paper is 100 marks. You will find 30 to 40 marks will be like simple questions, and another like now 20 to 30 marks will be sort of intermediate, and the rest will be more complex questions. Okay, so again, same thing will happen to Python. We're just guessing how the sort of weighting will look like based on a 100-mark paper. And then your Python, your question 3, again, now this is the big part of the syllabus. Because a big part of the syllabus, it should make the big part of your paper, right? So if you make stats 30 and Python 20, then you only left with 50 for Python, right? If they make Scratch 25 and Python 20, then this could be 55. Or it could be split into 2 questions, so you never know, right? So we just trying to give you some scenarios of what it could look like. But now, tips on how to prepare students for the Python program. Remember, you need to know things like variables, how to use a variable, selection structures. Remember, we're doing block programming, you need to have indentation. Marks will be allocated for that. Repetitions, input, output, right? Remember, definitely the Python program will come with an IPO chart. So the IPO chart will be there. All those lectures to teach programming in IT and computer science will tell you this. All programming questions will come with IPO charts. So you will see that, right? Explain to the students how to work on the IPO chart. What are your inputs? What are your outputs? Straight away, they can figure out what the inputs are going to be, what the outputs are going to be. The processes, the formulas will be there. They're just going to use the formula, but you can obviously make it in Python form. The good thing about Python, it's very simple language. Syntax is very similar to pseudocode. So what you see in the IPO will be very similar to how they can use it in actual Python code itself. So they need to know how to use that, right? How to use selection, the petition, how to work with input output. So if you can guide your student on tips on how to get marks in the problem solving process for these type of questions, even if they get the program wrong, program doesn't even run, it's fine. They can still pass if they declare variables properly, if they got the input properly, they produce output properly, they make correct use of selection, they use the right function formula. The program may not run, but they have the right formula. They'll get a mark, they'll get the marks for it. So it's very, very important to explain this to them. These tips are going to help them. And what we notice is that the students always, always, always struggle with the practical paper. Theory is easier for them. The practical part is harder because they have a very bad time managing their time. So please give them tips on how to manage their time. Sam will now give you also some other tips which she can use, and then we'll have Daniel will help us with electronic.
Thank you for taking over. Yes, so when it comes to the programming paper, I think in terms of other sections, I actually forgot to put in their functions. We know functions are also a part of the level 2 syllabus. So again, students will need to know functions. But like Shailendra was saying, when it comes to allocating marks, I mean, even though we're allocating marks for creating functions, there are steps that are inside a function where marks are also allocated. And then let's say a student didn't use a function, but they have that particular process covered in their main program. So marks can still be allocated for things like that. So yeah. So again, in terms of Scratch, remember it's going to be not creating games. I don't think you would have programs with multiple sprites. I think it's more testing the same concepts that students need to understand in programming, how to create variables, how to do arithmetic operations, calculate an output, display the output, make use of selection structures, your loops, etc. When it comes to Python and Turtle, it's very likely the pattern they have maybe repeated steps. So it's very important that students understand how to use looping structures. They might be even nested loops tested in this section because it's easier to test nested loops when you are creating patterns. And then, like we said, question 3 could be 2 questions, we're not certain, but we do know like half of the paper is going to be on the Python programming language. So again, The other sections that could be in would be files, lists. I think it's more likely to be lists and using the list functions because that's covered in more detail in level 2. And then of course, declaring and creating simple functions that just perform a task. They are non-parameter functions and they do not return values. That's very important. So a level 2 student just needs to know how to create a function that does something. No returning values, no taking in values. Yeah, so that's in terms of the programming level 2 paper. So thank you again. I think that's where I shall stop now. And I know I did take up most of the time, or we did. But Nathaniel is here to present on EDCR, so he will cover also very briefly. He won't go through as much detail as we did in terms of going through the textbook, but he will cover the content for EDCR for level 2 and level 3, and then also give you a few tips on preparing students for the examinations. So I'll stop sharing now, and then you can make Nathaniel the presenter. Thank you.
Thank you, Sam. Otili, you can go ahead. We've made you a presenter. Otili, we're seeing your screen in the first slide, but we're not hearing anything. There's no sound coming from your side. Okay, you can go ahead now and speak.
Afternoon, everyone. My name is Otinel Mogotsi. So I'll be presenting on the just overview on the ECDR, which is electronic component, electronic and digital concept in robotics in level 2 and level 3. So the subject is more of consists of 2 subjects. That is why mathematics is a requirement, because it has a background of physical science, particularly chemistry and concept of electricity on physical science, and also there are technical concepts that you are studying in this topic. So we have tried on the Macmillan textbook to explain each and every concept that you come across. For instance, what is electricity, different components like resistor, diodes, LED light emitting diode, for instance, and then also capacitor, inductor, and other components that will come across. So we are explaining even the SI unit, because the first topic, let me just go to this one. I don't know if you'll be able to see it. The SI unit, like in level 2, we are learning the SI unit, introduction to atomic theory. So that's part of chemistry, because that is where the charges, when they react, protons and electrons, when they react, the issue of covalent and ionic bonding, that's what they're explaining in topic 2. So the SI unit, you're just understanding like Ohm's law, and also the ammeter, the voltage, the current, and how to represent them in terms of the SI unit. And then the electrical supply systems as I've already alluded about the Ohm's law, the Joule's law, and also other theoretical aspects that are related to this. So it's fully based on, that is why the student, they must have at least mathematics as a background, because even though they might not have physical science as a subject in their grade 9 or grade 10 or grade 11, but as long as they have a mathematics, it will be easy for them to understand this concept. And then the other thing, the different types of components, like as I've already said about the resistor, the diode, the transistor, transformer, inductor, capacitor, all those different types of components that we have in, because this is more of is light current. So it gives a learner a foundation, because remember, we are in a robotics stream. So since you are in a robotics stream, you will be learning about the robotic as a subject, and also computer programming, basic computer programming. So it is very, very important now to understand the electrical part, because all components, all device, it might be a computer device, it might be the cell phone, might be a robotic device, they do have a circuit board. So that is where now you need to understand the circuit board. The learner has to understand the circuit board. So the Macmillan textbook is trying to explain some of the concepts. They also give pictures, for instance, of different components that I've mentioned them, and also the circuit board, either the Vero board or the breadboard. How do you put all those components on a breadboard or on the circuit board? So also the semiconductor, like for instance, we know that we have good conductors of electricity and poor conductor of electricity. So with the semiconductor, it has bit of poor conductor of electricity and also good conductor of electricity. Some devices, they require the semiconductor element. For instance, if you are talking about the robotics system, we know that it's a computer system, a computerized system, but it has a circuit board on it. That particular circuit board, it has some components. So the components are there to reduce the flow of the current, so that the current won't be too much, the current won't be low. It will be just on a level that the device will need in order to operate. Because at the end of the day, the electricity must be able to assist should not be too much. That is why the learner needs to learn about the components. To say, if we talk about the resistor, for instance, what the purpose of a resistor on a circuit, it do the opening and closing of the current, where the capacitor will store the current and release it in a particular time. So those are some of the concepts that are very, very important for learner to learn about them, to understand what is happening. And then also the symbols, how to draw those different symbols of the electrical components. They must be able to know how to draw them, and then also how to draw the circuit. This is very, very important, either connected in a series or connected in a parallel, but it is important for them to know that how to draw that one. Then the prototyping and designing, they will also be able to design. They can design on a paper, design on a paper if they are examination. Designing on a paper, they need to design on a drawing sheet. And before they can start working on the actual circuit board, they must draw it first. It's like what you're doing in programming, where you talk about IPO chart. The same as the principle of IPO chart still applies here, because where they do a prototype, they need to draw first before they can take it into the actual device where they are going to design a particular component. Then on the electronic tools and equipment, we are introducing also here. Macmillan provided the pictures of each and every tools and the components. That the tools, what are the tools and what are the components? They do have the components that, as I've already said, about the resistor, the capacitor, the inductor, the transformer, the relay. There are so many. Then we have the tools now. The tools like the Stanley knife, the side cutter, obviously the tools are other equipment like multimeter and also oscilloscope and function generator in level 3, the plier, all those that they are using them. So the soldering iron, the soldering wire that they need to build a circuit. So they need to know what are those tools and what are those components, for what purpose, why they are using them, and for why they are using them. So that's where they're explaining on the electronic tools and components. So there are pictures on the textbook and also explanation of what are these components and what is their purpose. And then on the digital systems and principle, that is where we see the relationship between ECD, ER, electronic and digital concept for robotics, together with robotic and programming. Because on the digital signal is where we are trying to analyze the difference between the analog signal and also the digital signals. We know that we are talking about the binaries, the hexadecimal, the octal, all different types of numbering systems that we are using in electronic system. So that's why now they need to understand those binaries, how to convert those binaries into the actual the PLC system. Because on the PLC system is where we will be talking about the logic gate. The logic gate, you are referring to the flip-flop. So when you talk about the flip-flop, that is a part of the computer science system, because a computer system is a flip-flop. It's a bistable system where you are able to have on and off at the same time. So that's why you're explaining this concept, just giving them the basic. And then the other thing, they need to learn about the workshop ethic. What is it that they're doing in a workshop? How to wear the PPE, how to use the PPE in a workshop, how to conduct themselves. They always in a workshop, because you are dealing with electrical components. Safety is very, very important, where you have to look at the safety shoes when you are working on a bench. The area must be clean. You must avoid all those unnecessary things, like for instance water, dust, because they might have electrical electrical impact on the device. That is why you must be able to always avoid them. It's about the safety of the user in the lab, and also the safety of the components, because some of the components, they are very, very small. Like for instance, if you are working on a Vero board, you are using, for instance, a LED or a resistor or a capacitor. They are you can easily bend the leg, or you can easily break a leg for that matter when you are working, because it has two legs. Like a resistor or a capacitor, it has a two leg where you have to insert them. So sometimes the other one is anode, the other one is cathode. So if you are not careful enough, you will be easily breaking the other leg, where the component will not be able to function. So that is why it's very, very important that they know the safety rules that are applying, safety regulation that are applicable in a lab. Also the safety signs, like the fire extinguisher sign, where you're able to see the sign for exit, the sign for entrance, for that matter. Because when they are in a real workshop, those are some of the things that they need to be aware. The hazard signs, and also other signs that are related to safety and to occupational safety and health in a lab or in the working environment. Then we are looking now at the topic level 3. Topic 3 is a continuation of the topic 1. Remember, the topic 2, in level 2, is the foundation. They are laying the foundation for level 3. So level 3 is more, now we are more detailed, where we go into for instance, the first topic is magnetism, where we are looking at the inductor or the capacitor, how the charge will flow. Because remember, in electricity, we talk about two charges. It's either a direct current or alternate current. So that's why we try to analyze that, to understand how the charge, if the charge is stored on the capacitor, then it's released from the capacitor to the inductor. What is happening on that one? So when we talk about the magnetism, for instance, static electricity, and also we have the normal electricity that you're using. And also we know that there are different sources of electrical source where we have, renewable electricity, non-renewable electricity, where you have the coal, you have the solar, you have the thermal, you have the hydrogen, hydroelectrical system. So those are the things that they are trying to explain there. And then electrical supply system, where they talk about the transformers, and then also they are connected current, whether in series or in parallel. We know that the transformer is one of the devices that will do the step up and step out. So the step up meaning it will increase the charges. The charges will be increased, or the charges will be lower. So they need to be aware, because they're going to build the robot. When they're building a robot, they need to use those components like a transformer, like capacitor. The purpose of a transformer on that, what's a purpose? It will store the current, but when the current is needed in a particular area, it will be able to enhance that amplitude to be higher, so that it will be able to supply wherever the electrical charge is needed. We have the DC, as I've already said about the AC direct current. For instance, if you're connecting a battery to a phone, that will be a direct current. But if you're connecting from the source to another source, like you plug electrical component on the plug, and then it will connect to another electrical supply. That particular supply to connect to another, that is an AC system, or the AC signal, the alternative current signal. Then we have also electronic components, and also together with the semiconductor. It's a continuation now where we analyze in detail those electronic components and semiconductors, because in level 2 we identify them, we know their function, but here we are trying to look on each and every electrical components, because as they are going to build a robot, they need also to understand how those components they function. If they say they need to include, for instance, the integrated circuit, and also the LED, and also the resistor, they need to know now, because they're going to build a device. That is why now we go in detail analyzing each and every electrical components, and how to see how they are related to the semiconductor. Then we have again electrical component, electrical symbol, as we have learned about that one, and also circuit drawing, we also is a continuation. Now on level 3, the electronic tools and equipment. That is why now we are using those equipment to analyze. For instance, if we connect, we build a circuit, then after building a circuit, then we use the oscilloscope. We are using the oscilloscope to see the signal, to understand the signal of the current. Okay, on an oscilloscope, it might be when it will form a graph. Whether the graph will be in a sine wave graph, or it will be a sawtooth graph, or it will be a square wave graph, or triangular, that will demonstrate. So this is, it will work hand in hand with the function generator. They work hand in hand with the function generator, because with the function generator, we are able to see the frequency, the time it will take for it to build a one wave, how long it will take. So that's what we are trying to analyze in level 3. In level 2, we're just giving a background, or the basic that they need to know the component. But in level 3 now, we are using the component to analyze those signals in order to understand, even to check, to test. We are using the multimeter to test the components, to check the polarity, to check the range of that particular component. We are using the multimeter. Then on digital system, that's when now we are using the PLC. On the PLC, as I spoken about the flip-flop, the logic gate. In level 3, PCP, principle of computer programming, I think on this programming also, you're going to learn more about that one, where you learn about gate, like AND, NOT gate, and OR gate. So the same principle you're going to learn here about those gates, where we also look at the programmable logic control. On the programmable logic control, that is an automation system where things are done by machine. So that's what you are learning there with the PLC, but it originates from the Boolean algebra. That is why with the Boolean algebra, that's why you'll understand those logic gates. To say if you are connecting two switch, for instance, two switch, and then also with a LED, or using one switch with two LED, and then we are putting a relay. So those LED, they are not switching them, they are not on, or they are not emitting at the same time. The other one will be off, the other one will be on. So that's a 0 and 1 in that way. So meaning when it's on, or when it's emitting or it's flickering the light, it will be 1. When it's off, and then it will be 0 in that way. So that's what we're trying to understand with the PLC. So that's where there is a huge link between the two, where you see the digital system.
I'm trying to get hold of Sono. Is it Sona? Sona. Yeah.
That's where you see the link between the digital system and also the electronic, the computer science, because that's where we are able to see how the two they relate, where you have a circuit board connected with the wires electrically, but you're able to interpret it using the PLC. You are able to interpret it now in a form of electricity, but you're also be able to see those AND gate, whether the input true or false. In that way, the bistable system, where you're able to see whether true or whether false. When it's true, meaning is 1, or the light is emitting. When it's 0, meaning is off, the LED is off in that way. So that's what we're explaining there with the PLC. Then we have the functions, the strings, and the data structures. They are part of programming also, where you explain this particular concept. Now, in terms of the preparation for the examination, okay, as my colleagues have shown, okay, let me just touch on the lesson preparation and also the subject guideline. When the Macmillan, they've looked at the subject guideline and also assessment guideline when they developed the textbook. So in other words, they've tried to look at all topics and also together with the weighting of those particular topics. So when you are teaching it, you know how many, as you can look at for instance, at this document that I've shared with you, the one that shows the level. If you go below, you'll be able to see the weighting in terms of how many percentage you must spend on a particular topic. So those are they're explaining there. The other thing, the Macmillan, since they are identifying those topics, that's where you'll be able to see your subject outcome and your learning outcome, so that we are able to see which topic are you covering for which specific outcome and which specific learning outcome. And then again, usage of learning material. There is a bibliography list at the end of the textbook where you are able to refer to other materials. And also there are some links. There are some links that are provided where you are able to go and search further about a particular concept. Let me say, if you are talking about the Ohm's law, and also you don't understand the particular law, you can read further where they provide the link for you to refer in that way. And then now we go to the assessment. The assessment and the final examination. Also on the assessment, they've tried to, we tried to include all students, where we have try yourself, we test yourself, we have individual, we have group activities. So these are some, and also examples are provided, especially for the concept where you have to do some calculation. Now the concept the examples are provided there. And then here for the try yourself, as well be given the examples or a particular concept where you're given a question, then you need to answer those questions. The answers are provided on the task guide. That's where you'll find the answers, the relevant answers for those assessment, whether it's a try yourself or test yourself or individual or a group activity, you'll find it there. And then also the adoption of the standards. So they try to, we try to look at the national standards. Okay, we know that this is a new subject altogether, but because we have experience from a previous subject like ECDE, electronic control and digital electronics that we are offering in our NCV program. So we have used that particular system to align our assessment to those of the national, so that we are not far away from what the national question paper, especially the examiners, when they are setting that particular question paper, they are looking at. And also you have the summative assessment, and at each and every, and we have a summary of the topic, and also we have the summative assessment at the end of the textbook. Also the marking guideline is provided there. Okay, as my colleagues have alluded for the examination, in order to prepare for the examination, the same standard that we have followed, where we have the multiple choice, especially for the level 2, the true or false, the match column, then we have the fill in the missing words, and then again, on the long question, we had some discussion and also the calculation, where you have to perform some calculation. As we know that it's a technical subject. So obviously there are some calculation that the learner must do at the end of the day by performing, trying to understand or to explain some of the concept. That's one. Then also remember that there is a paper 1 and paper 2. So on paper 1 is more of theory, where you'll see your multiple choice, the true or false, the match column, the fill in the missing words, the long question, and also the calculation. And then on the other part, where it's paper 2, it's more about designing, because some topics they require the learner to design, starting from topic number 4 up to topic number 6, where is more of practical, where it will require learner to design the circuit, draw the circuit. On that way, there is a special page that they are using to draw. Okay, I know that you're using freezing application also to draw a particular circuit. Thank you, Mr. Ken, and also Ms. Samantha. I think that's all from my side. Thank you so much.
Thank you very much to our 3 presenters this afternoon. It's been very detailed presentation, very in-depth, and I'm sure the lecturers have benefited tremendously from this. So I'm not sure if there's any questions. I haven't seen anything in the box, but you do have the email addresses, so you can liaise directly with the presenters should you have any queries. Once again, thank you very much. Thanks, lecturers, for attending, and we will make the recording available. So if there's bits that you missed out, you can always go back and listen and view it again. Thank you once again, and have a good afternoon.
Thank you again. Thank you, colleagues. Again, just a quick reminder that if lecturers want those boot camps and those additional trainings, to please contact us via email or even with WhatsApp. Thanks again.
Okay. Thank
Bye.
you. Bye, everyone.
Bye.